Hey, good evening, everyone.
Good evening.
There we go. Good evening.
Good evening.
Yeah, thank you. Happy Intersolar. Who all is here is attending Intersolar right now? Most? Half? Oh, decent, just only about half. Anyway, so during Intersolar, we like to do a state of solar software innovation. We've got a panel for that tonight. And who's first time here at a CleanWeb event? Okay, good. Only about a quarter. So for those of you who are new, we run monthly technology showcases to present innovative startups here in the Bay Area. We've also expanded to Seattle, New York, Portland, and soon to be cities beyond. But tonight's all about solar, and I want to give a big shout out and thank you to PG&E for being our hosts, for providing this amazing space and food. Thank you. So here is Pete to tell you a little bit about the PG&E Energy Center.
Thank you. Welcome. How many people here have never been in the PG&E Energy Center before? Hopefully, hands go up. Great. That's exactly what we're looking for. First off, we always have to do a little safety announcement. You know that in California. Things start shaking, get under the tables. As soon as they settle down, we'll go out this door, down down the stairs, out to the ground floor, half a block over to 4th and Howard to take care of any business that we have to do there. Bathrooms, as you know, are probably up against the far wall. There's more bathrooms down underneath the stairs, and everything goes into the compost or the recycling. Nothing goes into the trash. So the PG&E Energy Center is a ratepayer-funded facility that is funded by a small surcharge on everybody's PG&E bills. And we basically teach people all about energy efficiency, building design, architecture, solar. We teach people to use less of the product that our company sells. Is that an interesting business proposition? So if you don't know how that decoupling works, that's part of what I'm sure a lot of you know about how California is structured with decoupling and the utilities. But this is, I wanted to shout out here that this is probably, if you're looking for energy, this is probably one of the best deals you're ever going to find. We have free classes here, and I teach the solar track and the integrated renewables track. My colleague over here, Ryan Stroop, is a building teacher. He's been here for 20 years teaching building commissioning. He's a nationally known teacher on retro commissioning and auditing and all that sort of thing. We have lighting specialists. We have architectures. We have all kinds of things. So anything that you want to do to get into the energy field, broaden your horizons about energy, it's here and it's all free. I have flyers here that I will put up on the table over here and the table back here, which has our website on it. We also have an extensive tool lending library downstairs with over 5,000 number of tools, hundreds of different types of tools, blower doors and meters and sun eyes and all kinds of things. So if you want to use a tool, you wanted to try it out for your business, you can borrow it here first, have an expert train you on how to do it, and then decide if you want to purchase it for yourself or not, or you can keep borrowing it from us. We have vast experience on all kinds of big things, lots of buildings around here, including the Intercontinental across the street. That person is a LEED certified building and was one of Orion's mentors. And Obama used to stay up at the top there. It's a sort of a showpiece of energy efficiency. That's the kind of people that we deal with here, and it's a great resource. So I met Ravi a little while ago when he's exactly our goal was to reach out to people who hadn't been here before and sort of give a little plug. So we got a nice partnership here, and we're happy to keep going with it. So Ravi, take it away.
Thank you again, Pete. So quick little bit of housekeeping and announcements. Keep it short. Get the bulk of it for the presentations panel, and then some more networking and food afterwards. So CleanWeb was started to close the funding gap for early stage clean tech companies. And while a lot in this industry are deploy, we also, if we don't continue putting money for monies, if we don't put the capital forward for innovation, we aren't actually going to reach our goal of keeping temperature rise below 2 degrees. So far this year, there's been about $15 billion invested in clean tech, primarily in the electric and autonomous vehicle space. But solar's gotten a good amount and other energy factors. But as you can see here, only about 1% is going towards early stage companies. So that's why I'm creating this platform, and we're combining it with these physical meetups so that we can meet each other and support each other. So CleanWeb, whole mission, but the idea behind CleanWeb versus clean tech is to use software to solve resource issues. How you can get involved, build really cool tech, we can help you get it going. submit topics to for events, be a speaker, join us on thecleanweb.org, post your jobs, look for jobs. We've got lots on there. Share these meetups with your network. Join us on Slack if you'd like to keep the conversation going. Email me with any sort of questions, but not complaints. I'm very sensitive. So one thing, we just partnered with the National Renewable Energy Labs on their American-Made Solar Challenge to increase innovation and manufacturing of certain pieces of the solar pipeline. So at the end of this month, we're going to be doing ideation and team building workshop so we can look at some of the ideas that need to be solved and see if we can come up with some teams and problem statements. Then in August, probably going to take that off. I'm going on honeymoon. And then when we come back, yeah, thank you. Dan was at my wedding. He's a childhood friend that I didn't know was coming to here, so that was awesome. So in September, we're looking to cover blockchain for energy, both specific energy-focused cryptocurrencies, and then also just using blockchain more broadly. And then also, we're looking to do just a movie night, and we're talking about showing The Point of No Return, which is a documentary about the solar impulse. It was a solar-powered airplane that circumnavigated the globe. And one of the pilots actually flew over from Switzerland and was at the conference today. So that was super cool and exciting to meet him. Super fanboy. So that's about it. We're going to dive into the panel now. So I'll go back to the beginning here. So going from, they didn't line up in alphabetical order to their names, but we have Victoria Arch on the end from Angeza Designs, who works, she's one of the co-founders and chief of product, COO. I'll let them give more detailed introductions because that will be faster and much more eloquent than I will do. But so we've got Victoria from Angeza, we've got Eli from Voltaic, we have Ben from KWH Analytics, and we have Chris from Aurora Solar. So why don't we just go down this way and quickly introduce yourselves, your company, and what is the sustainability problem that your companies are solving?
Chris Hopper, co-founder and CEO of Aurora Solar. We are a solar software company. We make sales and design software for solar installers. The problem we're specifically solving is streamlining the process of going from an address to a proposal. So everything from system like layout, sizing, the specific electrical connections, financial calculation, shading analysis, and proposal generation, both for the residential and for the commercial industrial space. So that's what we do. We're a 5-year-old company. We grew out of Stanford originally. If I can take a minute for a quick, very brief history. My co-founder and I, we actually started out installing systems ourselves. The idea was to start an installation business focused on emerging markets, so installing commercial installations in emerging markets. And we did a 50 kilowatt system in Nairobi, Kenya back in 2012. And through that experience, we noticed how painful the sales and design process is, obviously exacerbated by the fact that we were here in the US and the system was thousands of miles away. But nevertheless, there's a lot of complexity that goes into designing a system and designing it well and designing it remotely. So that's how we stumbled across the issue that we're trying to solve now. If you look at the cost stack of a residential solar installation, only about 50% of that $20,000 you pay on an average system is the equipment costs. So we're trying to bring down the other 50% of that equation to make solar more affordable. Today, more than 50,000 systems are designed every month on our platform.
Just briefly about me, I'm a physicist by training. I actually started out in cell technology, so 3-5 solar cells, which are dead technology now for terrestrial applications. But then I got into data science out of that physics background. So on KWH Analytics, what do we do? Probably the easiest way to explain that is to start with the the genesis of the company, which is really a discussion between our founder, Richard Matsui, and the chairman at the time of a company called CoreLogic. Has anyone heard of CoreLogic? Oh, okay, 3 people. That's more than I thought, actually. So for the rest of us, and I also hadn't before I joined, CoreLogic are a company down in LA. They're a large public company. And what's interesting about them is that they have 99% of mortgages in the US they have data on. And as a result, investors feel comfortable investing in mortgages in that space. And the thing about that is that actually, if you look around at all sectors, all large sectors, they all have a company like CoreLogic. And what the chairman of CoreLogic said to us at the time is, if solar is going to be as big as you guys think it will be, there needs to be a CoreLogic for solar. So that's what we've been doing. We've been building out a software tool that allows investors to manage their risk. And through that, we are actually now have data on about 120,000 systems, solar systems throughout the US. So we actually have a second product, and what that product is a production guarantee. And so we've taken that 120,000 systems and we've gone and spoken to insurance companies, and we've persuaded them that actually solar isn't as risky as they thought, and that we have the data to actually assess what the risk is for any given system. And so why do you care? Well, probably don't, but I think you should, because that actually has a huge impact on the cost of solar if you can show that the risk is lower than you thought. And to understand why, you have to understand that if you're a developer, you want to build your project with debts, not with your own cash. That's much cheaper because the rate of interest you get from a bank is lower than the rate of return that you'd need. And you can obviously leverage your own capital. And the second thing you have to understand is a little bit wonky, which is that banks give themselves a bit of buffer because they hate risk. Banks are not the type of entity that takes on risks. So if I'm a solar project developer and I want to build a project, and I go to the bank of Ravi and I say, Ravi, give me some debts so I can build this project. They'll say, okay, I'll give you as much debt as you need, up to the point where the interest payments are about 30% lower than what you think your revenue is going to be. And that's his buffer. He knows even if my project really doesn't perform, he's still going to have that buffer. But it means I can't take out much debt because Ravi doesn't trust me. He doesn't trust solar. He doesn't know about solar. It's not his specialism. So what I do is I go to KWH Analytics, I get this production guarantee that guarantees 95% of production. And now I go to Ravi, and Ravi says, oh, well, Swiss Re are willing to put their name behind 95% of production. Now I'm comfortable. Now I can guarantee up to sort of 90% of what your revenue is. And so as a result, that actually makes solar projects more profitable, and the idea is that we can encourage more solar to get deployed.
It's true. My name is Eli Leland. I'm one of the founders of a company called Voltaic. And I guess I'll go in a little bit about the origin story. So what we call ourselves a battery intelligence software company, and we help the global battery industry as well as consumer electronics, electric vehicles, and grid energy storage work with the data that they're already collecting more effectively to improve their engineering productivity and the performance and reliability of their battery-powered devices and systems. My background is in energy engineering. I did a PhD over at Berkeley, studied kind of everything I could about energy, and took sort of a circuitous path, but ended up, after finishing grad school in New York City, working on an ARPA-E R&D project. For those of you unfamiliar with ARPA-E, it's a Department of Energy Advanced Technology R&D, Advanced Research Projects Agency for Energy. So I was working in a lab in New York City, doing some stuff with capacitors and power converters. There was another ARPA-E project in that lab, headed up by another Berkeley alum, that was developing grid-scale energy storage using alkaline battery chemistry, basically. So taking a Duracell and making it rechargeable and big and cheap and all those things. And as we were working on our two projects, leading these two projects in this lab in New York City, our group had developed some very basic, I wouldn't even call it software, just scripting tools to allow us to do faster data analysis, do extraction and some automated processing of the data coming out of our battery and capacitor test equipment, and do sort of remote look at stuff on the web from home so we don't have to come into the lab to get data, et cetera. That sort of turned out to be the inspiration for what became Voltaic. So we were leading these two projects. They were both hardware. We were supposed to both hit all the engineering milestones and also find commercial opportunities for them. But as we were bringing in potential partners, potential customers for these hardware projects, everyone wanted to know more about the software. And we actually got a couple inquiries to do some one-off consulting projects to build similar systems for some companies locally to New York area. So we sort of fast forward, we did that. We did a couple consulting projects. We raised some grant money from Department of Energy and National Science Foundation through the SBIR program. And that was back in 2012. And then in about 2015, we took on some investor funding. And more recently, we just closed a Series A round. And so we're growing from there. But I guess I'll talk a little bit more about the inspiration of the company from that from back in the lab. So we realized that that the battery industry, that batteries are very incredibly data-intensive devices and systems. They're very complex. They respond very unpredictably to different storage conditions, different operating conditions, and two batteries that come off the same manufacturing line can end up performing very differently in an actual, out in the real world. And being in this sort of academic and R&D setting, we were staying abreast of the latest and greatest in terms of modeling battery lifetime and performance and behavior, and found that basically all of the modeling techniques that people were trying to use to predict battery performance just weren't very good. They weren't practically applicable. And so this sort of, around the time, this was 2012, and so a lot of big data was kind of in the wind, and we were sort of thinking, hey, we're getting this commercial interest to build a software platform that we can run in the cloud that will basically take people's data that they're doing engineering analysis on batteries with, and accelerate their workflows, provide value. They'll pay us to host those systems for them. And in doing so, we could build up this very large data set describing real-world battery performance. And so that was sort of the inspiration. There was two inspirations for the company, basically like a workflow acceleration tool, but then also building up this battery data asset that we felt would become very valuable eventually. So that was back then. These days we're headquartered over in downtown Berkeley, so we ended up hiring a bigger team out there. I moved back from New York just a month ago, and we're about 15 people right now. We have, across those markets that I mentioned, we have some high-profile customers and global automakers and consumer electronics companies, and we're very big into product development, so helping our customers sort of either optimize their battery chemistry or the manufacturing process for their battery. When they make batteries, they test them, and then we help them do all that. We automate all the data analysis that leads them to iterate on their product. And then for the OEMs making mobile electronics or electric vehicles, we help them choose suppliers with a data-driven process and sort of keep their suppliers honest about are they getting the performance, are they getting the batteries that they are supposed to. And now we're starting to work with companies doing grid energy storage to apply our technology to troubleshooting and some predictive maintenance and things like that for grid energy storage. So I think I'll leave it there.
Great. So I'm Tori. I'm COO, co-founder of Angaza. We're a business-to-business provider of a pay-as-you-go software platform for solar devices sold in emerging markets. So I think of that as us sort of sitting in the value chain between manufacturers of these products and distributors of the products and providing a suite of services to both. So we work with manufacturers to help them integrate IoT technology into their products. So those products will switch on, meter, and switch off according to prepayment from an end customer. And then probably a bigger part of our business is to create a software platform for the distributors of those products to help them manage pay-as-you-go sales at scale. So I think of that sort of like a pay-as-you-go focused CRM. It's a front-end web portal hosted in the cloud, and then it has a mobile application. So these distributors can collect end customer data when they make sales. They can register that information on our platform. They can set pricing terms. They can manage payments and do portfolio analytics and all the things they need to do essentially to manage a financing business at scale in some of the most complex and difficult markets in the world. So we have been around for about 6 years now, really starting to scale at the beginning of 2016. We now have distribution partnerships in over 30 countries, primarily sub-Saharan Africa, but getting a lot more traction recently in Asia and in Latin America. And yeah, that's us in a nutshell.
Awesome. So now let's go back the other way. So what new technologies has your company developed in the last 12 to 18 months that's sort of a leap from earlier generations, and that's now propelling your company forward?
So I'm not sure how new this is from earlier generations generally, but for us, this is relatively new. So I'll just focus on that. We have, I would probably say, 2 different technologies that we've been focusing on recently that are sort of in contrast to each other, interestingly enough. In one case, we've been working on GSM-based communication with our products in the field, so actually using the data network to communicate with products to just do classic IoT activities, so switch them on, meter and monitor, and yeah, keep track of them essentially. That's been a great innovation for us because it's a much better experience for the end customer. They make a payment via often a mobile money network or a digital payment network. Then we wirelessly communicate with that product and switch it on, so they don't have to do any sort of activity or interaction with the product. But it has some shortcomings because obviously it doesn't work in places where there isn't network coverage. So required some innovation on our part around figuring out how to deal with edge cases where a product moves out of network or network comes in and out. Do we then send a key code? Then you need to have it that they can enter into the product to transfer that data information to the product. In that case, you need to have a keypad in the product. So there's just been a lot of sort of thinking around how best to optimize that technology, but something we're really excited about. The other thing that we've been working on a lot is an offline version of our mobile application. So that's why I said it's kind of a contrast to GSM because it's focused on enabling sales of pay-as-you-enabled products in places that are completely offline, which is opening up whole new regions for us, especially interestingly enough in Latin America. Africa tends to have, broadly speaking, really good mobile data coverage. But offline versions of the sales app is complicated because obviously you can have asynchronous data. So if an agent goes offline for quite a long time and is making registrations and making sales and collecting payments, then you're back in headquarters and you really have no insight into what's happening with that product. So then you have questions around how often that agent should be coming back in network. Do us as Angaza enforce that they come back in some sort of frequency? Do we let the distributors choose that frequency of syncing? Do we allow complete usage of the app forever without syncing? What does that mean for us as a service provider in this place in case anything goes wrong? So yeah, those have been things that we've been focusing on and have been really interesting advancements for the company over this past year.
Right. You did it without me saying the second part of the question, which I forgot, is what lessons did you learn or unexpected findings did you come up? So the other 3, you are pre-armed from what she already did. So,
cool. Battery data is obviously the lifeblood of our company. In the last 12 to 18 months, we've really made a big push to expand the types of battery data that we can bring into our platform. And give our customers tools to work with. So, when we first started out, we basically wrote an importer for one very specific data format from one brand of battery test equipment. And over time, as we expanded our customer base a bit, we started onboarding data from different types of battery test equipment, et cetera, until we built up kind of a little portfolio for some random obscure data formats from battery testers. But all along, the vision has been that if we can take any data stream of time series current and voltage describing a battery, that we'd be able to derive, all of our sort of value-added analytics that tell you a lot more about what's going on inside the battery. So I'd say in the last year-ish, we've made a big push to expand that. So now that's actually sort of coming true, where we can take just a text file that's dumped out of a battery management system log from a grid energy storage system. And if we can set up a configuration file, so if we know which columns are the current and voltage, and if they have it broken down at sub-module level and things like that, we can bring all of that data into our platform. Similarly, we've begun onboarding data from the CAN bus in electric vehicles. So there's this specialized data bus, which vehicles use to communicate, data around the vehicle between different computerized systems. So the electric vehicle battery pack uses that. So we can bring on data from that format as well. And the reason that that's valuable to our customers is, as I mentioned, once we bring this data in, we do what we call we have these what we call harmonization analytics, which take that data from any of these different formats, and everybody's ultimately collecting current and voltage data, but there's a lot of other things like you integrate the current over time to get the coulombic capacity in and out of the battery, and you multiply that by the voltage to get the energy in and out of the battery, et cetera. And then there are dozens and dozens of additional derivatives that we can take off of those data streams. That we then use in our analysis to make predictions and diagnoses about things that are going on inside the battery. So previously we'd kind of do that in a one-off way. Each time we'd get a new customer, they had a new type of test equipment, and so we'd rewrite all our analytics to get it into that format. But I think we took a step back about a year ago and said, okay, what does the importer look like that could take any data from any source and abstract it and then put it into this common format? And what that does for our customers is that they can be testing an individual battery cell in a product development lab from a potential supplier, and then they can compare that in our same system to the performance of a vehicle that's out in the world driving around, and kind of do that same apples to apples comparative performance internally. And then the other, I guess this it's a bit arcane, but the performance data that describes the battery, the current and voltage, that's really just telling you you can kind of think of that as like the output of the battery. That's like how the battery is performing. But the input data set is all the metadata describing how the battery was made, what the manufacturer was, where it was operated, kind of anything you can tell about that. And so we've also expanded our capability in terms of bringing on both structured and unstructured metadata describing the batteries. So initially our tool was basically just kind of like a data file browser for people doing battery engineering, but now it's kind of a more comprehensive database describing both this qualitative properties of the battery and how it was operated, and then the actual quantitative performance of the battery. And so, I think the lesson learned from that work is, and this is kind of I think this is a universal truism in like the big data field, but get your data clean before you get it into your system, because it is a real pain. Once we have a customer that we imported a whole bunch of their data. It's actually the metadata, all this data describing what the battery was, who the manufacturer was, what lot number, what plant it came from, and turned out that was all manually entered at some point way up the chain. And so once we started trying to build real analysis on that, we found that data set was actually too dirty to use. And we've been going through basically like a 6-month process of cleaning up that data set, and it's a big pain. And even if it had taken 6 months on the input side, I wish we cleaned it up before we got it in the system, so we would have known where we were.
Good lesson. Ben, you probably know a bit about cleaning up data.
Yeah. So I guess this may be a cheat because we've been working on it for longer than 18 months, but I would say most of the work that's gone into it has been the last 18 months is our entire risk model that we've built on top of our solar data. So I sort of take off my Richard CEO hat and put on my data science hat and describe what it actually is. If you read anything about data science, machine learning, etc., basically it falls into two buckets. You're trying to categorize things, or you're trying to like predict some value. What's really fun about this is we're not really trying to predict a value. We're trying to predict a probability distribution, which is a challenge you don't normally have, right? You don't come across that kind of challenge normally. It's been really fun, actually. So just to describe what it is that we built from my perspective, it's you take a system that you're planning to build. It's got this sort of tilt and this azimuth. It's got this orientation. It's got this particular inverter model, this particular panel model. It's located in this specific site, and it's going to be installed by this specific person or installer. All of those things affect what we think the risk is based on our database. And then to build a probabilistic model that's built on top of our own physics model of what not just what we think the production will be in any given year, but what is the distribution of what we think the production might be. So if a transformer fails and you can't get a replacement, it might be 50% of what you thought. So you have to model those edge cases as well. What happens if a volcano erupts in Indonesia, spews out a load of sulfates, and global irradiance is reduced by 2% that year? So all those kinds of interesting edge cases have to be in that model. It's not just your sort of standard physics model. So that's what it is. What have we learned? I think the main thing that we all learn going through this process is how hard it is to work with big insurance companies. It's sort of like if you're in a canoe and you're trying to persuade the Titanic to sort of go around you. They're these huge old companies that don't really like risk, because that's their job not to like risk, and they don't really like to trust someone else who's this smaller company to just tell them what the risk is. So to get them comfortable with accepting that you know what you're talking about is a pretty tortuous process. I'm not sure I'd want to go through again, but we got there. And I also learned that it's actually more fun than I thought from the technical perspective of actually modeling those things. So I never thought it's an industry I never thought I'd be in, but I'm glad I was. A second thing, which is sort of less key to what our company does, but I think it's worth mentioning because it might be relevant to some of you, is there is a DOE project called Orange Button, which some of you might have heard of. But one thing that I learned in the last few years in solar is even though solar is a big industry, most of the data on it is transferred in PDFs and Excel files that live in folders on people's Windows machines, and they're sent as attachments in emails. And solar industry now is like, it's got to the size that that's no longer really a viable way to do things. And so there is a DOE project, and we're one of the participants in that, called Orange Button. And the idea is to standardize the data format that everyone uses for any type of solar data. So I would encourage you, it's in development at the moment, and what we're specifically working on is a tool that will ingest all the different flavors of data that solar providers are using, and if not, they'll be able to download a sheet that very clearly tells them where to paste everything, upload it, the tool will ingest that, and then it will spew it out as in the correct Orange Button format, so then it can be distributed to anyone. So I would encourage you to read about that. That tool that I described is still in development, but it's coming out very soon in the next few months. So we're really hoping, we're not really going to profit off this, but we're really hoping that it'll move the industry forward in terms of their data standards.
One of the major, I guess, advancements we made last year or last 12 months was, actually, let me rewind. So one of the core steps in the workflow in our application, given that we do primarily rooftop systems in residential and commercial space, is, well, modeling the roof, right? And the better you can model the roof, the better you can figure out what your radiance is on the different roof planes, where to put the modules, how many you can fit, and so forth. So it's really a core part of the workflow. The trouble is it can actually be quite complicated to model roofs because they're not all just a simple gable roof or a shed roof, right? That's you have that in some areas, but it can. I've looked at, I don't know, thousands, tens of thousands of roofs now, and I'm still amazed by how complicated and non-standard these things can be. So we spend a lot of times thinking about roofs. That's about the fun part of my job. I kid, but it's a part of my job. And so we developed a tool we call the Smart Roof tool, which basically streamlines the modeling part of the roof modeling part of our software. So the way it works is you effectively just trace out the outline of the roof, and the software will create the interior structure of the roof for you based on some smart assumptions and a couple algorithms we developed and actually also filed a patent for. And then you do a few adjustments, like you remove a roof plane that's not actually there, that the software assumed was there, and voila, you have your roof. And you can actually also compose more complicated roofs from simpler structures. So 2 simple gable roofs, model them separately, kind of move them together, smash them together, and the software calculates all the intersections and composes this complicated roof model for you, basically automatically and interactively. So it's a very powerful way of modeling these roofs without actually having to be an expert in AutoCAD or even SketchUp, which is complicated, still quite complicated to use and takes a lot of time. So you can model a complicated roof in a matter of seconds or minutes, whereas in a generic CAD program, it would take you way longer. So that was a key part of innovation because it's really central to our workflow, and we're also big believers in data and also before the sale, before the design, making data-driven decisions. So it's really important for us to provide our clients with tools to make smart design decisions, and this is a key part of that process, because ultimately we believe this will lower the cost of solar if you make smart decisions up front and optimize system performance and so forth. So this was a huge development for us and a big success too. The lesson I would say we learned is that is all around user, change management for users, right? Even though it's a very powerful tool, it is still a process of moving your existing user base that's used to certain interactions and behaviors to this new technology. No one likes change just for the sake of change, and people have a job to do, and they're used to a certain tool set, and if you don't do anything, then for the most part, they're going to continue doing that. So it's been a big piece of learning for us how to communicate the value in that and other products. This kind of generic piece of learning that you can apply to anything you develop, and the steps you need to do to educate. Well, someone tried to attack you. How to educate the user base and kind of change the behavior over time. Yeah, so that's something we also now incorporate in any sort of.
Did you move all of your customers over to the new tool right away, or did you sort of stagger it?
No, so some are still using the old tool, so it's a work in progress. But yeah, so the kind of process of managing that change has been something that we've learned a lot about.
Nice. All right. So now your innovation, what about your competitors, frenemies, partners? What have they developed in the last 12 that's really impressed you or has stoked your competitive fire to create something even better?
This one?
Yeah. We can go inside out. I mean, change the flow. Anybody, if somebody has something, you just...
Sure. I mean, I'll take an easy part. So a partner of ours is Nearmap. I don't know if anyone's familiar, but Nearmap is an aerial imagery company that basically flies planes and captures imagery. And that kind of is in the vein of, we're very much aligned in providing data to people to make design or smart design decisions. So we partner with Nearmap to provide that imagery in our application. So, we make it accessible, but, it's very much them who, came to the market, and they fly planes in most metropolitan areas, twice or sometimes even 4 times a year. So you can see what's called leaf on, leaf off, is exactly what it sounds like. So you can see the roof once, without the leaves, and once see the leaf cover to model the trees and the shade impact. So that's a very exciting development for us, because provides us with data to provide to our clients to help them make better decisions and thereby be better at their jobs. I know that's a cop out because it's not a frenemy.
You don't need to name competitors or frenemies, but I mean, if there's just something else like within the specific,
So, for example,
field that you play on.
I really appreciate the efforts of companies like Solar Reviews or Energy Sage, because lead generation and customer acquisition is a big issue for solar installers, and any efforts in that area are well appreciated because it makes it eventually will bring down the cost of acquisition, which will bring down the cost of solar. And I think they do a great job of educating homeowners about the benefits of going solar and different decisions they need to make, and then funneling that sort of lead flow to installers.
Yeah.
So I think that's a great initiative.
We don't have many competitors that are doing the same thing, but we do have one competitor doing something similar, which is just an insurance company called HSB. Stands for Hartford Steam Boiler, because they started out just insuring steam boilers. Yeah, now they insure solar too, and so they were competing pretty well with us, and it was kind of confusing to us because we didn't have any. They didn't have any solar data like we did. So how did they understand the risk? And what we realized was in their policy form, when you read the small print, all they were insuring was how much sun you were going to get in a year. They weren't insuring whether your inverter was going to fail, whether your panel was going to fail, anything. It was just how much sun was going to fall. And that's something that anyone can easily understand and model that. There are weather data sources out there. So it's very easy for them to get comfortable with that risk. So we had to make an effort to go out and educate customers that this is you're not getting what you think you are, and these two products are very different. And it was sort of a wake-up call to me, at least, just that you can be doing all sorts of clever things with data, but you've got to make sure that actually has value that people recognize in the real world. And that's certainly, me as a data scientist, I think I can be guilty of sometimes not not always doing that, of getting too bogged down. So, yeah.
On the solar puts, how are people, or is that part of just the product now? It's like when somebody becomes a customer of your risk management tools, do they just get the production guarantee in that, or is that something that they purchase within the stock? You can buy a put option, things like that.
Yeah, right. It's actually the other way around. It's if they buy the put option, they get to use our risk management tool as part of that, but not the other way around.
And are you seeing people do that? And have you had have any of those been activated? Like the inverter or the Anggung, the Mount Agung in Indonesia that just went off? Did that affect and have any of these been called?
Yeah, no, we haven't. We haven't had claims yet. It's still relatively early. I'm sure we will. With respect to Mount Agung, the volcano risk is actually relatively low. Yeah, it is feasible that could push you over the edge if you for example, the winter of 1815, which that was a huge eruption, and that was when Frankenstein was written, actually, because that winter was so poor because of an eruption in Indonesia, partly. And there was crop failures and things, so that was a lot of sulfate. So something like that happened, it's feasible, but it wouldn't be catastrophic in terms of solar production even then. So, yeah.
Awesome. What's currently in the external tech advances from universities, from national labs, et cetera, or market or regulatory changes are you seeing that you're really excited about, either for your companies or for the industry abroad, that you say, oh, this is going to be a major mover? Maybe we're getting way too wonky here.
I mean, the one thing that makes me just excited is to see the cost curve continue to come down. I think ultimately that's what it boils down to, is how cheap can you make this, and how reliable can you make it, and how it can help people make data-driven decisions and understand this and bring down the cost through these things. And I mean, that trend has been there for the last couple of years, and I don't see it stopping. And the more the industry matures, the more specialized players like us in the software space, design space, like companies here in different parts of the market and other companies that are not represented here, start chipping away at this. So I remain very bullish about that. The sort of just incrementally shaving off, the cents per watt will compound and have a massive effect down the line. It's a very interesting industry, so there's also bumps, and we can talk about those too, and evolution of net metering and all these kind of questions and policy things. But on the whole, just that macro trend, I think, is strong and gets me very excited.
I add to that, which is that I think actually the mood in solar was quite bullish, and one of the reasons for that was that there's been a decision you guys might be familiar with recently from the Chinese government to slightly remove subsidies for for installing solar. And you guys are probably also familiar with the fact that there's been recent tariffs on importing solar panels, which seemed like it was going to have a fairly large impact. But because there's less demand internally in China, right at this moment, for their own production, that's actually reduced the price of solar panels, which has helped the market here to sort of ride those tariffs. So it's actually surprisingly bullish into solar right now.
I'd talk about a similar trend in batteries, just of the really incredible cost reductions in the price of lithium batteries over the last couple of years. They're sort of dropping much faster and more dramatically than anybody predicted, and that's having a lot of follow-on effects. I think one of them is sort of tracking something that happened in the solar industry maybe about a decade ago, where if we all think back to 10 years ago or so, for those of us who are involved in this community, there were tons and tons of solar startups and people developing all kinds of new thin film technologies and printed solar technologies and all kinds of things like that. And then the market was shortly thereafter flooded with a tremendous amount of very, very cheap solar that was just good enough, and it kind of killed all of that sort of entrepreneurial and R&D activity, but it led to just this very wide deployment of solar. And I think we see something similar happening in energy storage, where there have been a lot of companies working on a lot of interesting and innovative things in battery and energy storage technology. But lithium batteries have just gotten so cheap that they're just getting out way ahead of all these competing technologies that we're sort of shooting for low targets that lithium has now dropped below. And so that's obviously bad for the entrepreneurs that are trying to develop these new technologies to compete with lithium. But I really think that it's good for everybody else, and it's leading to things like just unbelievably dramatic reductions in the cost of power coming out of solar plus storage projects that are going in. And I just was hearing some talks earlier this morning that there are projects getting at least getting contracted now that are they're going to be able to sell energy cheaper than a coal plant, which was unthinkable 10 years ago for anything having to do with energy storage, because it was so expensive. But that also brings with it some risk, because the batteries are getting so cheap, they're getting very commoditized, and the supply chain is kind of exploding. There's tons of new suppliers coming on, and there's a lot of very large battery producers, say in China, that whose names nobody knows, but those batteries end up getting aggregated through dealers and various transactions, built up into modules and systems, and deployed around the world. And so there's a fair amount of risk, because we all know when you have a quality problem in a battery, that can lead to literally explosively disastrous results down the line. And so it carries some. It's exciting because the costs are coming down so much, and it's really inspiring. And in spite of whatever kind of headwinds there are, the technology is just getting so much cheaper that I think a lot of the visions that probably a lot of people in this room have had about being able to transition away from fossils are going to happen. But there needs to be some some sort of way to trace that quality of the supply chain as this becomes this sort of global foundation energy technology. And so that's exciting for our company because that's part of our vision is ultimately to become that sort of data layer that provides that transparency and traceability on every battery from production through assembly into systems through field operation, ultimately second life.
So going back to what you said, Ben, about the tariffs, how have those tariffs affected? I know it's generally they've affected the solar market some, but or you guys actually have a physical product, and that's primarily what the tariffs are on, and then subsequent retaliatory tariffs from other countries, and you deal in 30 countries now. So how have those tariffs and subsequent responsive tariffs affected your businesses?
Yeah, so this is interesting for us because we actually don't manufacture anything anymore. And I think that's obviously protecting us in this case. So early days at Angaza, we produced our own lamp, and then we produced our own sort of integrated pay-as-you-go product inside of the lamps. And now we've moved completely away from that. So we provide sub-circuit specification to manufacturers and firmware, but we allow them to do all the manufacturing. We assume that they know how to source and manufacture for optimal efficiency and all of that stuff. So it's purely consultative for us. So we're protected from pretty much all of this stuff.
Anything specifically from you three besides just sort of the general malaise of the solar coaster? No.
No, I mean, it's been kind of as described. So, I mean, some of the tariffs were offset, some was priced in already. So also we're in the residential and commercial space, which generally is there, the percentage of the panel cost of the total system cost is much lower. So the sensitivity of the system cost and thereby demand to that is not as high. Mm-hmm. Already 50%, like I said, is only the equipment, and then only part of that is the panel. So for that reason, we haven't felt it in any major way. No.
It seems to be especially hard on the utility scale space where the margins are thinner on equipment. One thing, it's hard to say like how much the tariffs impact it, but definitely it's very competitive for developers right now. And so they're trying to like eke out more value wherever they can. So at the conference, that you notice if you go around the panel manufacturer booths, pretty much everyone has some kind of perk cell that they're developing and trying to sell, which is like a next generation higher efficiency design of cell. And I actually think it's potentially good for us because we're a way to add value without cost. Another layer that developer can add on to try and squeeze up their IRR.
Have any questions from the audience? Yes.
Yeah, I'm just wondering.
I'll just repeat. Are any of the panelists planning to roll out AI or machine learning to improve predictive performance? Well, that's sort of what you do already, Ben, but...
Yeah, we're at Voltaic. We're working on some of that stuff as well. So that's, again, going back to, part of our inspiration in starting the company was building up this very large database of battery performance. And an obvious thing to do with that is to apply machine learning techniques to do predictive modeling. So we have done some of that. In fact, a grant that we got from National Science Foundation when we were just starting the company, this is like probably 5 years ago, was to do exactly that. And we did it. We actually did a big design of experiments. We had some battery testers in-house. We generated a bunch of data. And we showed that we could, exceed the predictive capability of kind of prevailing techniques using, some pretty basic machine learning stuff. But when we went to bring that out to our customers, the market just actually wasn't really ready for it yet. The big battery industries have historically been pretty backward just in terms of their data and analytical capability. And so we find that we're actually trying to help a lot of these companies catch up while we kind of in the background work on these predictive techniques. But we do plan to start rolling out some of those things in our product around the end of this year or early next year. And it's and we have a couple customers specifically that we're doing similar sorts of things on a more sort of a professional services basis. So rather than using our big aggregate data set, they want us to look specifically at their own data and see what kind of predictive things we can do.
Most of our distributors, or many of them at least, the majority are selling to end customers that have really no digital identity to date. And so that's one of the reasons to have this technology that switches the products off, because that allows them to kind of manage some of their risk, because they're holding the financing risk for these products, selling them to customers who have no credit score or credit identity at all, and then trying to make collections on those. So one of the things that we are doing is now we have a big enough data set that we are able to start doing some of this predictive work to help our distributors get a sort of preliminary credit assessment of people they're selling to before they sell them the product. And ideally, that will help them mostly right size the product that they're selling. Obviously, most people want the biggest, most powerful product they can get their hands on, but they may not have the buying capacity for that. So Angaza has products from solar lanterns that really just replaces a kerosene wick lamp all the way through a large home electrification kit. And by helping provide some sort of initial credit assessment of that potential buyer, we can help the distributor choose which product is probably the right size for the buying power of that particular customer, and so that they're most likely to be able to pay it off, and then they can upsell them to a larger product and keep kind of moving them up the energy ladder. So yeah, we're starting to do some work around that. It's been really interesting.
There's one plug I'd like to make for a collaboration we have with NREL called RD Tools. So if any of you have any production data and you're trying to figure out what the degradation rate is, we've actually collaborated with NREL. Figuring out the degradation rate is difficult. There are lots and lots of hairy issues with that. So if you're interested in that, there's a GitHub repo that you can go and take a look at that we're working on with NREL called RD Tools. So that's some sort of separate machine learning to what we...
The letters RD.
Literally the letters RD and then tools.
Deal as much with time series data or forecasting in that sense. I mean, we do production estimates, but that's kind of physics-based modeling that we do. We do have a team that's focused on sort of machine learning, but more in the computer vision direction. So obviously, we look at, as I said, roofs a lot and aerial images in general, and we, want to streamline that process. So any insights we can generate automatically are, of interest and to us and of value to our clients. So one feature that we have currently that I can talk about, it's not directly small computer vision and machine learning in this case, but we have a feature that helps our clients identify obstructions on commercial rooftops. I don't know how many of you have looked at commercial rooftops, but
Do a raise a hand.
yeah, who has?
Really?
Okay, they tend to be kind of large, fairly rectangular-ish buildings, but there's actually a lot of stuff on them. They're flat, but there's ducts and there's AC units, and if you have a large kind of a Costco or some Lowe's distribution center, these can be like, some buildings are like half a mile long or something like that with a lot of stuff on it. So manually tracing out all these things is painful. So we have a tool that lets you identify obstructions automatically, and that saves a lot of time for our clients. So that's one of the ways we derive insights based on those types of techniques for our clients.
Yes, John.
As the growing size of your
As the data sets have grown, can you make a business case just to sell the data itself? Are you selling the data that you've collected? Put it another way.
So in our case, our customer agreements empower us to use aggregate data sets to do things like benchmarking and train predictive models and stuff like that. But we don't. I think yes, there would be demand for our data if we were willing to sell it, but we're not going to sell it. That would violate kind of the confidentiality we have with our customers. But we feel that there is going to be tremendous value in the aggregate data set and things we can do with data in aggregate that doesn't involve selling the actual data.
I think same from us, really. It would be illegal for us to sell our data, and it would also be sort of a poor business move, because that's where our value is as a company. So, but what we do in the same way is sell products that are based on aggregated data. So if you're a developer, you can see how your data compares to the aggregate of the industry in a specific location, for example. So take the data, increase the value of it, but decrease the amount of information.
Sam, okay. Do one more and then I'll do a final question.
Sure. Final question. I guess the two players I was curious about.
Does KWH Analytics work with large institutional investors and banks, or just insurance companies?
Yeah, and by banks, you're talking about not banks who are lending to developers, but rather banks that already invest in their own portfolios as an investment, right? Yeah. Okay. So yeah, and I think in both of those cases, they are customers of that first product I described, where they're able to use our SaaS product to analyze the risk of their existing investments. Does that get your question?
Okay.
There was a gentleman behind the column.
Oh, didn't see. David, did you go for it?
So what do you think about
The question was, what are your thoughts on community solar?
I mean, I think it's a very exciting trend, and I think it's a market segment to watch. We'll see a lot more growth in the future. I think that's the gist of it.
Okay. The other ones don't really deal in community and solar so much. All these enthusiastic, solar workers, are any of you hiring? I know they all are because they all have jobs on our platform. So, what are you hiring for, and who wants a job? Just say one or two jobs that you have, and then we'll go around if anyone else is hiring.
Yeah, we're hiring across the board. Best if you look at our careers page, but it goes from people operations, sales, customer success, also technical customer success, as well as the engineering side. So many ways to fit in. And if you're just generally interested in what we do, also just grab me afterwards or reach out. Be happy to chat.
Yeah, so we're hiring for a data scientist and for a data engineer. And also we're hiring for a business development person, senior business development person, who should have some background in finance of solar.
We're hiring for a couple different positions. UX designer, that's a pretty urgent one, so would love to talk to anybody who's interested in that, knows people. And then on the engineering team, we're also hiring a DevOps person, a senior front-end engineer, a data engineer, and a back-end engineer. And we always want to talk to people who, battery scientists, battery engineers, people like that, especially people who like working with data coming out of those systems.
So we are hiring for several positions as well. Senior software engineer, full stack, Android developer on the engineering side. I think that's where we are right now. And on the business side, we're really looking for an instructional designer to take over a lot of our help desk strategy and thinking through all of our just all of our sort of training and self-help materials, and that's something that we're having trouble filling. So any recommendations on that would be super, super helpful. And we have a lot of open positions. A lot of our customer-facing positions are in Nairobi. So if anybody's interested in moving to Nairobi and having an adventure overseas, we're hiring for customer success, sales, customer support, and primarily those three, and some engineering roles in Nairobi as well.
Awesome. Anybody else hiring? We'll just go from this side. Going right here.
Hi, my name is Sam. I work for STEM. Do battery stuff, software stuff, and we're back. So, data and
Anybody else? Past the midline, going the pillars. All right. Well, with that, I want to thank the panel again. Just give them a round of applause. So we still got a bit more time before Pete's going to kick us out. But I see Garrett Nielsen from the Department of Energy just arrived, and I invited him to tell a little bit more about the American Solar Prize. So, Garrett, if you want to say a few words.
Yeah, so my name is, I don't know where to stand. This is awkward with the poll. I'll kind of stand behind you guys, I guess. All right, yeah. Hey, everybody. Yeah, so my name is Garrett Nielsen. I work for the Department of Energy's Solar Energy Technologies Office. I'm the program manager for our technology to market program, and I also lead our soft cost program as well. So just really briefly about what the Department of Energy does, we fund early stage research in photovoltaic materials, power electronics, anything related to the production of solar energy and its integration onto the grid, including concentrating solar power as well. And then we also think a lot about how do we actually, turn stuff into something that would actually impact the marketplace. And so we've launched what we're calling the American-Made Solar Prize, which we hope this is the first round of hopefully many to follow. So what is different about this is that we're really, trying different methods in terms of providing funding. Normally with the funding opportunities we do, you write some long application, as a couple of these guys can attest to. Maybe you hear from us a while later, then you get some money, and then you have to do a bunch of reporting on that, and it's just a blast, as I'm sure Christian could tell you how much fun it is. But what we're trying to do is use prize authority, which is something that's relatively new to the Department of Energy, to deploy funds faster and lower the burden both on us and particularly on you as the innovators. So the American-Made Solar Prize is something that we announced about 3 weeks ago in the middle of June. There's a lot of dimensions to this, so I'm going to give my best explanation of it that I can here. And I have a billion of these cards here that I can hand out, and I'm happy to answer questions as long as people are willing to hang out. So essentially, it's a multi-tier prize competition. So right now, we're actually in the part of a competition which we're calling ideation. So the first thing that we're admitting is that we actually don't know all the problems in the solar industry. So we're asking people in the industry to come to the website on the card, and I think as you can see somewhere up here, or no, it's just a picture of the website, but you can get to it. Anyway, I'll pass that around. To just put up idea statements. Like, what is a problem that you have that you wish someone would solve that maybe isn't, something that you planned on solving in the future? Or let's just get ideas up about the stuff that's standing in the way of getting solar out there. So right now we're open for people to submit ideas. I know myself and my team are going on there and starting to put up ideas of what we think are interesting problems to solve in the solar space. The first deadline for people to compete is October 5th. So on October 5th, those people who think they have an interesting solution to some of the problems that might be out there, or if you have your own problem that you want to solve, that's fine as well. We draw a pretty wide sandbox as terms of what solar is. So it could be around grid integration, materials related things. It's a pretty wide breadth, but either way. So the submission requirements for the first contest is a 90-second video, and you have to answer 4 questions, essentially around what do you want to solve? Why is it important? Who's your team? And what's your plan? Depending on the number of applicants that we get, we'll be awarding anywhere from 20 to 40 people. They will split $1 million in cash. So that's anywhere from $25,000 to $50,000 each. They will then have the opportunity to come back about 3 months later and compete in a second competition, which is kind of a down select, where there will be a demo day and things of that nature. At that point, we'll be awarding 5 to 10 groups of people a next award. In that case, it will be anywhere from $100,000 to $200,000 in cash. And then coming with that is a $75,000 voucher for use at national labs or maker spaces to try and prove and push your product further. Then about 3 months after that, we'll have the final competition where 2 entities will, and anybody who won the first competition, so any of the 20 to 40, even if you don't win the second competition, can still enter the third. Well, you will get up to $500,000. You'll get $500,000 in cash on the spot, and then you'll get another $75,000 lab voucher. So over the course of about 6 months, you can take in on the order of $700,000 in cash and about $150,000 in vouchers to leverage National Lab physical facilities and the actual staff that is at the facilities as well. You know, these are the kinds of groups that Kilowatt Hour is engaged with and the like, and Aurora is engaged with as well. And there's just a tremendous wealth there of information that's available there. So that's kind of the quick competition. The idea is that we'll be starting the next round of the competition basically 6 months out from where we are now. We expect these to be rolling multiple times a year for people to put in ideas, for people to submit their solutions and so forth. Hopefully, if this works really well, you'll see the Department of Energy roll out prizes around everything else. So there could be this time next year a vehicles prize, a buildings technology prize, a water prize, and things of that nature. One other thing that is a little bit different about this, and that also might interest a number of you in the room, is we're also admitting something else, which is hard for the Department of Energy to admit, is that we actually don't know everybody, as shocking as that might be. So what we're doing is we're asking people to become what we're calling connectors. So you can sign up and say, I'm interested in being a connector. So what does a connector mean? So a connector is someone who can help bring people into the competition. So if you bring people into the competition and they win that first prize, you get $1,000. They win that second prize, you get $5,000. They win the grand prize, you get $10,000. So the idea is to help bring people into the competition and then actually have you actively help them move their product forward, help them bring them to resources. And so right now on the website somewhere, I forget exactly the link, there's a map covering of dots across America of all the connectors who've already signed up. We have coast-to-coast groups, and you know we're always looking for more people. And it actually doesn't stop there as well. As a connector too, we're also looking for people to help potentially bring money into the competition. So help raise money for the entities that are competing. Maybe even bring money to the National Renewable Energy Lab, where the people are actually running this whole competition, for future prizes in future rounds. And so the three groups of people who are able to bring the most money into the competition then will also split $100,000 at the end of the competition as well. And again, this is something that we plan on doing over and over. So these prizes are going to be topped back up, and we'll do it again, and we'll top it back up, and we'll do it again. So while it says it's a $3 million prize, there's actually a fair amount more money that will go out to connectors and the entrepreneurs. So we're actually very, very excited about this new format. It's a much lower barrier to entry for people to submit their ideas. And also it's just a new way for us to try to engage with the community. And so we really ask everyone to help spread the word about this. We're really in the early stages of outreach. Like I said, the first competition isn't, submissions aren't due until October 5th. But we're really looking at stuff that, you know, stuff related to solar manufacturing, stuff related to hardware that can be made in the US, hard software. So what's stuff that is going to be really, really challenging to build out over time. And we're really here to help kind of jumpstart you as companies or help build out a larger, what we're calling American-made network of people who could support fledgling entrepreneurs. And there's no limit in terms of the size of entity who could be involved. So you could be one person or you could be working at First Solar doing something kind of as a side gig. The only limit is that in order to win the second prize, you have to incorporate in the United States in some way, but that's a relatively low barrier to entry these days. So I'm more than happy to answer any questions that people have. Like I said, we're looking for people to help submit problem statements, people who want to get involved as solution developers, and then people who want to act as connectors and to really help expand this network and really make it into something that is sustaining and can go out into the future. So we're setting aside funding to hopefully do this for a few years out, but we're in kind of the first lap of it right now. So I'll kind of stop there and happy to answer any questions. I see a question here.
Concept include hard and soft costs?
So the question was, it include hard and soft costs? Either. I mean, we were really, there's a big focus right now on manufacturing and hardware in this administration, so we certainly are looking for that. But if there is, you know, a software solution that can uniquely drive down costs related to solar and it's really challenging, then we're willing to think about it. So we're not going to draw a specific boundary about it at this point. Yes. All right, how are we going to judge? So inside of the rules document, which you can get to through here, is a list of the criteria that we're going to use in order to judge the submissions. So the submissions will be judged by people from the DOE, but we're also going to bring in external experts in the industry to help judge as well. And so, the first round will be essentially looking through videos and the written submissions, and a subset will be selected based on the feedback that we get from everyone involved. And then the last 2 rounds for the higher dollar amounts, there's actually going to be in-person demo days and that whole kind of thing as well. But there's a whole list of criteria available in the rules document. All right. Well, I have like a million flyers, so I'm happy to hand them out. Happy to answer any questions. I can even answer questions about community solar as well if people are interested too. So thank you very much for your time.
Thanks, Gary. Thank you, everyone. As you can probably guess, we're one of the connectors. So we're doing an ideation team building meetup at the end of this month. I'm still grabbing a venue for that, so it'll be posted on our meetup page within the next week or so. So if you're not a member of this meetup and you found it for some other way, it's meetup.com/cleanwebsf. So thank you all, and now let's continue this until they kick us out. Thanks.
Yeah.
So
You guys based in the city?
So
Yeah, we're
some
just a few
distributor
blocks
sells
away,
somebody
actually.
solar
Product, yeah.